This video is going to cover fossil fuels and the associated pros and cons with each of the different types of fossil fuels. So we're going to talk first about non-renewable energy sources. So let's start with coal. Now, coal is created from forests which grew around 300 million years ago. As those forests, the vegetation there died, they were buried, and over time, with more increasing heat and pressure, we got different levels of coal. So we start with peat. So peat is our lowest level of coal formation. Peat is found in things like bogs that are anaerobic in acidic environments, high pressure, that break down this organic material over time. It can be dried and used as a fuel, but it generally kind of looks a little bit like mud. It doesn't look like we'd expect coal to look like. If you look here, that as the peat is compressed between layers of sediment, it begins to form what's called lignite. This has the lowest percent carbon, and it's also the least dense. Moving on, it gets further compressed and forms what's called bituminous coal. This is more dense, higher carbon percentage. It's not shiny, but it's more black and it feels a little bit heavier. Lastly, we get anthracite, which is the most valuable and highest grade. This is the most ideal type of coal to be used in domestic heating because it's almost pure carbon. And so when you burn it, you get the least amount of smoke. It's shiny and dense. So what we find as we move from peat down to anthracite is that we get, here I'm going to delete, let me erase all this over here. So what we find as we move from peat down to anthracite is that we get increasing heat and pressure, which gives us a more dense coal with higher percent carbon. Why we want this is because coal that is more dense burns hotter and therefore gives us more steam, which leads to more electricity. So looking at the next slide, we see that the U.S. is a large producer of coal, but most of the coal that we make here is bituminous and subbituminous coal. So that's the subbituminous is between the lignite and bituminous coal. We don't produce a lot of that anthracite, which is that most valuable, highest grade coal. Our largest coal producing areas, number one is Wyoming. They produce more than the top other 4 states combined. But we find that a lot in Pennsylvania, West Virginia, Kentucky, and then Montana and Wyoming. So the big takeaway here is the higher energy density means that more energy is released when a fuel source is burned. Therefore, anthracite, which is an example here, it's shiny and it's dense, is the most valuable form of coal and the highest quality. So coal is our most abundant fossil fuel. We use it mostly for electricity and some in industry, so this would be to power machines. How it works is basically the coal is burned. You see here, coal is burned, creates heat, warms up water, which makes steam. The steam spins the turbines. The turbines go to the generator, which then give us energy to our transmission lines. The U.S. is one of the largest coal-producing countries. We have 300 years of reserves, followed closely by both China and Russia. Problems with coal is that it leads to something called industrial smog. So industrial smog, you're going to need to know this. We're going to talk about it more in our air pollution unit. But for the purposes of this, we're going to say that industrial smog is made up of particulate matter. I'm just going to abbreviate that as PM. That would be small bits of things that are contained in the smoke put out by the coal burning. It has sulfur in it, and it also has carbon monoxide. Burning coal also causes acid rain, also releases mercury, and mercury is a problem because it leads to bioaccumulation. This comes up again in a later unit, but bioaccumulation is the mercury getting into our food chain and then getting accumulated as you move up into larger and larger animals in the food chain. And it also releases CO2, which leads to global warming. So these environmental problems of the industrial smog and the mercury and the CO2 give us air pollution, which leads to respiratory problems. The bioaccumulation gives us mercury in our tuna. This is why you have limits on the amount of tuna you should be eating. And then the miners themselves suffer from black lung disease. This being said, coal does have some advantages. It's very abundant, particularly in the US. It's inexpensive to get, and then coal burning plants themselves are pretty cheap to build. Coal is 30% efficient, meaning all of the coal you burn, 30% of that goes to energy, and the rest escapes as heat. So I want to take a moment to talk about cogeneration. So cogeneration is when the heat that is produced from electricity, so that 70% that's lost in coal burning to heat, is used to provide heat to a building. So it could be used to create hot air or hot water. So combining these things together gives us more than 90% efficiency. This is better than both coal or natural gas alone. So we can see in the top example, the fuel, they're losing a lot of it to heat in the power plant, and the boiler loses 9%. So instead of doing these things separately, use that recycled heat to come back and power your buildings, heat, and hot water. So the next non-renewable resource we're going to talk about is petroleum or crude oil. You're going to see it written both ways. So crude oil, or petroleum, is formed similarly to coal. So we have dead and decaying organic matter that's trapped as fossils underground. Over time, we have the heat and the pressure compresses the oil, or the organic matter, to give us oil over time. So what's important to note here is we've got a couple different things. So the oil and the gas rise through a permeable rock. That's right here. It's called the reservoir rock. Until they become trapped by an impermeable rock layer or a cap. That's right here. So our source rock is where we had our fossils. Over time, the heat and pressure causes them to become crude oil or natural gas. Those things rise up through the permeable reservoir rock until they get trapped by an impermeable layer underground. What we do next is we drill a well. That's this right here, this well. So we can reach the deposits and pump out that liquid oil under pressure. So when looking at oil formation, we also have something called tar sands or oil sands. These are really popular in Canada. So oil sands are a combination of clay, sand, water, and bitumen, which is a non-liquid form of oil. So we can see here, it's very viscous and it's attached to the sands and the water. The issue here is you have to use lots of water to heat it up so that it becomes a liquid and they can melt it and get it out. And then you need all this water to separate the oil from the impurities, which are the sand and clay. So we've more recently discovered ways to access the bitumen in the tar sands or oil sands in Canada. So Canada's become a big supplier of fuel, but it's not an easy process and requires a lot of water. So petroleum or crude oil is used for transportation, to make plastics, and in some cases it's used for electricity. So I want to draw your attention down here, and this is our oil refining process. Basically, we take our crude oil, which is the oil from the ground, we heat it up, and then we distill it into a distilling column. And so it's going to heat up so that the heavier materials are hotter down here at the bottom, it's cooler up here at the top. And this gives us the different types of crude oil products. So up here you can see that gas is a 4-carbon molecule. We've got heavy gas oil, which is 44, lubrication oil, kerosene, diesel, naphtha, gasoline, based and split apart by their densities and temperatures. So the biggest user of crude oil is the United States. We're wealthier, therefore we have more cars, therefore we use more fossil fuels, specifically the petroleum. Our biggest reserves are in Venezuela, Saudi Arabia, and Canada. Again, this is from the oil sands. Pumping and extracting the most is done in the US, Russia, and Saudi Arabia. So power is generated, because it comes mostly from transportation here, through internal combustion engines. This is your engine in your cars, your trucks, and your trains. So problems of oil and petroleum is that you have to make a lot of roads to get to the drilling areas. This can lead to habitat fragmentation, which is breaking up the natural habitat of an animal. Again, we have photochemical smog. Photochemical smog is made up of NOx. We're going to talk about this more in the next unit, but note that there's a lot of nitrogen products produced, particulate matter, and ozone. These things lead to respiratory problems such as asthma in people. Our advantages, though, and why we use crude oil despite these issues, is that it's easily available. It's in a lot of places. It's very high energy dense, so you get a lot of energy out of the product, and it's reliable. We know that it's going to work every time. Last but not least, we have natural gas. So natural gas is a process similar to the oil. This is the gas portion of the decaying organic matter. It's mostly in marine organisms. So the decaying remains of the plants and animals are buried under the layers of rock. Over time, they are converted by pressure and heat into natural gas. Natural gas is mostly made up of methane, which is CH4, which is a greenhouse gas, and is found on top of the oil deposits. So you can see down here, we have gas-rich shale. So we have a seal. This is that impermeable rock layer. Gas is trapped by that impermeable rock layer, as it is with the oil. Natural gas is the cleanest fossil fuel. It produces fewer air pollutants and CO2 than the other fossil fuels we've discussed today. So we use it for cooking and heating, electricity, and transportation. Almost 50% of Connecticut's fuel is produced by natural gas. So the biggest users of natural gas is the United States and Russia. Flip-flops based on costs and different political factors, but for the most part, the US and Russia are the biggest two users. So energy is produced the same way as we talked about for coal, heating up water, creating steam, turning turbines, going to generators, coming to us. In cooking and transportation, it's just combustion, the same as fossil fuels. So we see a lot of natural gas in places where we have a lot of shale. So most of our natural gas that comes to us here in Connecticut comes from the Appalachian area or down here by Alabama and Louisiana. That's piped all the way up to us. So this leads to some of the environmental problems, which is that it's piped all over the country, which means the pipelines can explode. It releases some CO2, particularly in building the pipelines. And then the fracking, how we access the natural gas, can contaminate the aquifers. And, let's add this, it can also lead to earthquakes. So there's toxic gases from released here that can cause asthma, and we can mitigate these in the ways that we treat the gas before it leaves the factories. But overall, natural gas is our cleanest and most efficient. So it produces 1/2 as much CO2 as coal. There's virtually no particulate matter, and it's 60% efficient. So 60% of everything produced is actually going to become energy, which is way more efficient than coal. If we compare the different pollutants here, we've got carbon dioxide. It's much less than oil and coal. Carbon monoxide, higher, so higher than oil but less than coal. It's got less nitrogen oxides, less sulfur dioxides, very few particulates, and no mercury, which is important. And that is our fossil fuels.